Hi everybody, welcome back to the Feynman technique. Today we're going to be evaluating this integral that I got off the channel Maths 505. The solution process is going to be almost the same. I'm going to be skipping a lot of the steps that involve solving integrals that you can solve using traditional Calculus 1 techniques. I'm just going to be jumping to right to what those answers are. But anyway, let's get to it. So our first step is to create a function of t that's equal to, well, pretty much the same thing as this original integral, except we're going to take the square, that denominator 2 there, and just replace it with a t. And then we can notice a couple things about this function. If we evaluate it at 0, we're going to get 0. So f of 0 is equal to 0. And if we evaluate it at square root of 2 over 2, we're going to recover our original integral. If this t right here was square root of 2 over 2, that's just 1 over square root of 2, and that goes right inside the square root as a 2. All right, so we can say that f of square root of 2 over 2 is equal to I. All right, so now what we're going to do is we are going to take f prime of t. That is going to be equal to the derivative with respect to t of this. And using the Leibniz rule for differentiation under the integral sign, we can bring that derivative directly inside as a partial derivative. Now, there's no way to write partial derivative in Desmos, so just know that this is a partial derivative with respect to t. All right, now if we evaluated that, this is just going to turn out to be this. Well, not that. It's going to be the integral from 0 to pi over 4 of that dt. And let's make sure that's actually correct. I'm going to put this function of t. It should graph this. I don't know why it's not graphing this. Oh, that's a dx. Sorry. Okay. Now I'm just going to put a ddt in front of that and make sure that it matches up. It does. Okay. Let's make this back to the normal prime symbol. Okay, so now we have this. This integral is actually solvable with traditional techniques. What you would do first is make the substitution that tangent x is equal to sine u. Now, I know that's kind of a crazy substitution, but it works. Do that, and then use the tangent half angle substitution, which is u is equal to tangent of, or x, yeah, u is equal to tangent x over 2. You could do that all in one substitution if you wanted to. And then solve it like that. It's a complicated integral, but there you can absolutely solve this integral using standard calculus techniques. It's basically just substitution. That's all it is. It's clever substitution, but it's still just substitution. So we're going to jump right to what the answer is. And what that is going to equal is this. We're going to have f prime of t is equal to pi square root of 2 over 2 times 1 over 2t squared plus 1 minus pi over 2 times 1 over 2t squared plus 1 times the square root of t squared plus 1. And let's just make sure that lines up. Let's call this f1 of t and make sure that it's equal to the derivative with respect to t of that. It is. Okay. I'll make sure there's no mistakes. Okay, so now we have f prime of t, but we are not interested in f prime of t. We want f of t. So what we do is we say that f of t is equal to the integral of f prime of t. I should really use the correct notation. I've always put f1 because it won't graph f prime if you use the proper notation. You have to put the subscript 1. And that's going to be equal to this. It's going to be equal to integral dt and then integral dt. Okay. So, this one should not be any problem to solve. This one is a little bit trickier. There's some work. You can use trig sub though. You can use trig sub and evaluate this using standard calculus one techniques. Again, it's a tough one, but it's doable. So I don't really want to go through the process of showing how that's done. Let's just jump right to the answers. So what we're going to get is f of t is equal to pi square root of 2 over 2 times the antiderivative of 1 over 2t squared plus 1, which is arctangent of square root of 2t over square root of 2. And we're going to have minus pi over 2 times the antiderivative of that, which turns out to be arctangent of t over the square root of t squared plus 1. And then, of course, we have a plus c. All right. Well, we know f of 0 is equal to 0. We're going to use that fact to solve for c. So f of 0 is equal to 0, but it's also equal to this thing when our t is equal to 0. Well, if this is 0, well, if this is 0, this is 0, and then this is 0, and all this is 0. So that's just 0. And if this is 0, then this is 0, then this is 0, then this is 0, then this is 0. So it's all just 0. So 0 is equal to 0 plus c implies c is equal to 0. All right, now we also know that f of the square root of 2 over 2 is equal to our original integral I, but it's also equal to this, and I won't copy the c because it's equal to 0. It's equal to this when t is square root of 2 over 2. And if you watched Math 505's video, you already know what the answer is going to be. But let's just plug it in. All right, let's simplify. This 2 is going to this square root of 2 and this square root of 2 are going to multiply together to give us a 2. And then dividing by 2 is just going to give us 1. So we have arctangent 1, which we know is pi over 4. Oops, I forgot to plug in square root of 2 over 2 in for this c. All right, so we're going to square this. That's going to make this a 2 and this a 4. That's a 1/2. We'll call this 2 halves. So that gives us 3 over 2. And then we can put that on top as a square root of 2 over square root of 3. And then this and this multiply to get 2, which cancels this 2. So we're left with just 1 over square root of 3 inside that arctangent. Multiply the top by square root of 3 and the bottom by square root of 3 to get square root of 3 over 3, which I believe that is pi over 6. Yes, it is. Okay. So we can replace this with times pi over 6. All right, let's do some more simplifying. This square root of 2 is going to cancel this square root of 2. This is going to become a pi squared over 8. Pi squared over 8. And this is going to become a pi squared over 12. Common denominator there is 24. That's going to be 3 pi squared over 24. And this is going to be 2 pi squared over 24, giving us pi squared over 24. All right, guys, I hope you enjoyed that, and we will see you next time.